Good afternoon, everyone. We are about to start session 2, the future of artificial intelligence, machine learning, and data analytics. I'm Mohammed Alam. I serve as the Dean of Engineering at Texas A&M University in Kingsville. Joining me as co-moderator is Dr. Mark Christensen. He is the Dean of Engineering at Southern Methodist University. We have 3 distinguished panelists in this session. The first one is Dr. Frederick Chang. He is a professor of computer science at Southern Methodist University. Our second panelist is Dr. Raymond Mooney, professor of computer science at University of Texas at Austin. Our third panelist, as printed in the program, is Angel Diaz. Unfortunately, he left IBM just before our program, so, but we have someone better than him, hopefully, and that's Daniel Hernandez. He is the Vice President for Data Analytics and Artificial Intelligence. So with that, I would ask each of our panelists to introduce themselves, and then each of them will have about 12 to 15 minutes to talk about each of these topics, and then we'll have about 15 minutes time for question and answer session. So I would ask Dr. Fred Chang to introduce himself.
Okay. Hi, I'm Fred Chang. As Alam mentioned, I'm the computer science professor at SMU. I'm also very recently the head of the computer science department. I'm primarily a cyber guy, though do dabble a bit in AI. I'm the former director of research at the National Security Agency, and pleased to be here.
Hi, Ray Mooney. I'm a professor at the University of Texas at Austin for the past 31 years. I'm also director of the Artificial Intelligence Lab there and worked in a variety of research problems in machine learning and AI and natural language processing for the past 35 years or so. And again, I'm also happy to be there. It just took me an hour and a half to drive down from Austin this morning.
Oh.
My name is Daniel Hernandez. I am the upgrade to Angel Diaz, 100%. I've been at IBM. I just celebrated my 12th year. I joined 12 years ago with a plan to leave in 2. I've been here since. Since coming to IBM, I've been focused on anything and all things related to data. In my current job as the Vice President of Data and AI, my job essentially is to set strategy and drive the portfolio for our data and AI products, which in aggregate represent the largest software business in the company and one of the strongest growing. It includes the DB2 franchise, the InfoSphere franchise, SPSS, and Watson.
Thank you. So with that, I would ask Dr. Fred Chang to say his introductory comments.
Okay. So pleasure to be here, and yeah, I have a few comments to start with. So I think the timing of this particular panel session is outstanding, given the 2018 Turing Awards were announced about 10 days ago, and people here probably recognize that. So basically, Yashio Bengio, Jeff Hinton, and Jan LeCun won the award for the work they had done in neural networks, deep neural networks. And much of what we'll talk about today can really be traced back to the work they did starting really in the 80s and 90s, and I'll actually touch a little bit on their contributions through my comments. The title of this panel talked about how the fact that the panelists will discuss how universities should prepare students for a future world dominated by AI and data science. So this particular phrase, dominated by a future world dominated by AI, is the sort of thing that people said 50 years ago. So AI has been around, and I think we'll all probably talk a little bit about hype and reality. So AI is, as a field, is basically sort of getting ready to retire. The first conference was in 1956, so that would make it about 63 years old or so. It's been around a very long time, and through the 50s and 60s, symbolic processing and Newell and Simon and a number of names you're probably all familiar with. Basically overpromised in many ways what AI could do. It basically led to something called an AI winter. So essentially the latter part of the 70s, there was a large downturn in funding and activity in AI because people basically overpromised, overhyped it. There was then a recovery from that. It then led to expert systems, list processing machines, something called the 5th generation computer project, and then again, sort of a lot of hype. That also subsequently led to AI winter number 2. So basically in the late 80s and early 90s, we experienced a second AI winter. Okay, so now we've just had the Turing Award named, so we've seen the rise of intelligent agents, of artificial neural networks, and now the question is, will there be an AI winter number 3? So it'll be interesting to see what other people's take on it. So Gartner tracks something called the hype cycle, and AI right now is probably at the very top of the hype cycle. I doubt it could get more hype than it is. So it is undoubtedly the case that it'll have to come down. Right? Nothing can stay at the peak forever, so it'll undoubtedly come down. I guess I'm of the mind that even if there is a correction in all the hype, the technologies that we've seen take place, particularly over the last 10 years, the advances in artificial neural networks and machine learning have made tremendous progress. So even if there is a reduction in the hype cycle, I still think what we're seeing is here to stay. And it'll be interesting to see others. But a note of caution is advised because it's happened before. Okay, so speaking of what's happened over the past 10 years ago, and again back to the Turing Award that was just named, the technology of artificial neural networks and machine learning is extremely effective now. So in image recognition, language translation, speech recognition, game playing, biology, text generation, there are texts generated now that are largely indistinguishable from how a human would generate text. I saw this interview from a fellow who is the CEO of a language translation company, and according to him, within the next 1 to 3 years, over 50% of the work in language translation that is currently done by humans, he thinks will be handled by machines, and that accounts for something like a $40 billion market. So you do hear from people who are actively working in areas that could potentially be replaced by humans, being afraid that, gosh, this could have a lot to do with my business. Last month, I chaired an AI and cybersecurity session at the National Academies, literally last month, and the question we asked there was, how can AI augment the task of cyber defense, just like it is augmenting language translation, just as it is augmenting image recognition and so forth. So the potential for these kinds of things to help in other domains is distinct. There are thousands of researchers working in neural networks today. So again, the Turing Award comes out in 2018. Over the past 10, 15 years or so, the advances are significant. So thousands of people are working in the field. There's a paper published on neural networks about every 20 minutes in 2018. The top neural network conference sold out in under 12 minutes. It was like 11 minutes and 37 seconds or something like that, the NIPS conference in Florida. Hundreds of billions of dollars have been invested in AI startups. So basically, it is just the thing now, right? It is just sucking up all the oxygen in the room. Now, it is fair to say that the field of AI is expansive. The classic text in the field is Russell and Norvig. The text itself is about 1,000 pages. There's maybe 50 pages on deep learning. So there are just a bunch of other areas of AI that are important, but the attention it really now is in deep learning and artificial neural networks. Okay, so getting back to the specific question, the way universities, from my perspective, will prepare students for this upcoming trend in AI is really about hiring trained faculty who can teach the students the skills that they will need to be successful. The universities who break the code and figure out how to do that will win. All of you in the room are going to be competing for the very same people. I've known Ray for a while at UT. I was at UT for a while, and he'll comment on this as well. But we're all looking for the same kinds of people. And so look to your left, look to your right. You'll all be competing for the very same people. And the talent is scarce. They're receiving these crazy job offers now. A newly minted PhD could well be offered maybe mid 6 figures. And if you have some experience and you're a well-known researcher, you're making 7 figures. And low 7 figures, it's just not uncommon. And when faced with the prospect of that kind of money, they may be quite interested in being an academic, but when you're offering maybe $500,000 or something and you're right out of graduate school, it's extremely tempting. So it's really hard, and so we're all going to be competing for the same people. So you're thinking, gosh, can I eke out another 5% or 10%, or I can increase the startup package, or I can increase lab space or facilities or a compute cluster or something. The private sector is going to be offering the person 4 or 5x the salary. Really tough. So in my mind, that is the biggest challenge. But with that said, any smart and bold investment you make in this area, I believe will serve you well. I mean, again, we're at the peak of the hype cycle, but even if it is corrected, this technology is here to stay, and it's making big differences. You've probably all heard about the big announcements made on either coast. So MIT makes a big announcement, Stanford makes a big announcement. They're both talking about billion-dollar investments in buildings and hiring faculty and so forth. I mean, these are big deals. Carnegie Mellon is just completing the first year of the first undergraduate major in artificial intelligence. I believe other universities will follow suit. So we're seeing universities making decisions, making big decisions, and that will have long-term impacts. Let me put the talent gap and the sort of capacity crisis in AI a little bit in context, because it is in fact true of computer science more generally. So I have a few facts that I'm going to read to you. So the number of undergraduates majoring in computer science between 2013 and 2017 is up over 100%. It's over doubled in those 4 years. During that same period, the number of tenure-track faculty members in those ranks rose about 17%. So over 100% growth in students, about 17% growth in faculty. There's your comparison. Same statistic for doctoral students. So the number of doctoral students in that same period rose by about 15%. So 100% growth in students, 17% growth in tenure-track faculty, 15% increase in graduate students. So basically, the undergraduates are getting paid, they're not making high 6 figures, but they're making decent salaries, so they're not bothering going to graduate school. They're going to work for the private sector because they can make awfully good money there, and it's just really difficult to have trained people teaching computer science. 1 more minute, okay. Okay, so I have 1 minute, and I'll skip to the end then, and then pick up some other guys. Okay, so in terms of a few comments on ways to help prepare. So thought number 1 is think interdisciplinary. So there are going to be a bunch of fields that are going to be users of artificial intelligence. So think liberal arts, think digital humanities, think computational chemistry, computational biology. They're all going to be interested. Think about offering minors in AI. So the students won't necessarily be able to double major in maybe 2 hard fields, but they're going to want to be interested. They're going to want to know more. So think about including minors as a way to supplement that. Think also about kind of 2 tiers. So there are going to be a bunch of really interesting tools that companies produce that will do quite a good job of ingesting a bunch of data and making reasonably smart decisions about them. So you don't necessarily need to have everybody who can design new algorithms or design new tools. There will be plenty of tools that chemists and biologists can use. So I do see courses that give people some critical thinking in using the new tools, but then there will be others that will have to be deeply technical to design new tools. Okay, the third one, think about partnerships. So think about partnerships with the private sector. So I've said to you that a bunch of faculty members and potential graduate students are going to work with the private sector. Maybe you can figure out a way to timeshare the talent between, maybe they work for the company in the summer, and maybe they can teach a class or 2 during the school year, so that they may still have an interest in teaching. They still want to make the big money in the private sector, but think about partnerships to share the talent, because there's just not enough talent to go around. Think long term. So artificial neural networks were basically something in the sort of mid-'80s, right before AI winter number 2. And it was sort of a backwater, right? At the time, people were interested in planning and predicate calculus, expert systems, predicate logic, and so forth. And this neural networks thing sort of sprang up. Well, 35 years later, it's the big thing. There's going to be something else. So think long term. Change is very unpredictable. Fifth thing, prepare students for the job they're going to have 3 jobs from now. So when they graduate, they're going to have some job, but there are stories about to what extent will their knowledge become obsolete. I like to think about sort of 3 categories. There's coding, there's computer science, and computational thinking. It's easy to learn to code in some sense. You can learn that in 12 weeks from a coding camp. Getting a degree in computer science for 4 years is harder. But then there's this notion of computational thinking, sort of thinking very critically, thinking in ways that will allow you to be effective in the job 3 jobs from now. And my final point is think about ethics. So even if a super intelligent machine isn't around the corner, and that's an interesting discussion that people love to have, AI will be making decisions that are critical, that are potentially life critical, system critical. We heard from the energy sector in the prior section. So these machines will be making decisions without the benefit of human input, expose students to the ethical issues these sort of decisions demand. Okay.
All right, let's move on to our next panelist, Dr. Mooney, and he will basically use PowerPoint to make his points.
Okay, I guess I'm the only one that actually made PowerPoints for this. So, okay. So I just want to put a little bit on my background. So as I briefly mentioned at the beginning, I've had like 35 years of research experience in AI and machine learning. It's been interesting to see what's happened to the field over the last number of years. And in particular, I got involved in machine learning when there were like 40 people in the room in 1985, and then I became president of the Machine Learning Society, which runs the International Machine Learning Conference for a few years. So I've been doing this for quite a long time, and it's been interesting to see how things have changed. So Fred's already sort of presaged some of my comments. So I lived through this boom period of AI in the 1980s that he also alluded to, based on so-called expert systems, where you tried to get people to manually engineer knowledge in the form of rules to solve problems ranging from medical diagnosis to chemical mass spectroscopy analysis. Those were 2 of the big success stories. And the technology was hyped. There were high expectations. It never really lived up to its expectations, and so it led to this thing that Fred alluded to called the AI winter in the early 90s, where investment was greatly cut back. So then machine learning sort of took over starting in the 90s. So that's an approach to AI where we try to, instead of manually engineering the knowledge, we learn it automatically from data. The key thing is that requires a sufficient amount of data that humans have labeled with some sort of, the biggest study problem is classification. So the classic example is spam filtering, where Google collects all this messages that have been labeled as spam and not spam and uses machine learning to train their spam filter. And that's much easier and more effective, it's been found, than manually engineering knowledge and try to write rules that define what spam is very difficult. Learning it from data, if you have millions of examples, is easy. So machine learning also is not a new thing. It actually started, the first neural networks were developed in the 50s. And there was an initial wave where you could just train one neuron. Very simplistic models. But then in the late 80s and the early 90s, we saw in the technology develop where you can train what's called a 3-layer network. Whoa, we go to 3 layers of connected model neurons. And now that we are in this, there was a lot of development of machine learning in other areas other than neural nets. Fred also alluded to this, about rule learning, Bayesian learning, using numerical optimization, things like support vector machines, which then eventually led to this new boom that we're in, the so-called deep learning revolution, which I dated here as starting maybe like not quite a decade ago now, where we have now methods that can train hundreds of layers of neural nets with millions of parameters training on gigabytes or terabytes, millions and trillions of examples, all collected over the web. Particularly, there have been these famous techniques developed. CNNs were, that's why Jan LeCun, one of the winners of the Turing Award, was critical in developing this technology for vision. Recurrent neural networks, which have been used in machine translation and speech recognition problems in language understanding. And then I know people have heard this recent success story out of DeepMind, which is now a part of Google, that won, the Go game by using what's called deep reinforcement learning. So I think there's been a lot of progress over the past decade. And I expect that progress to continue a reasonable amount over the coming years. And it's going to have a lot of impact on future applications. One, of course, a lot of people talk about is autonomous vehicles and how many jobs that's going to take over. Conversational agents, presumably you all have some sort of Siri or Alexa or something that you talk to on a daily basis maybe. Home and industrial robots. So I think all of this is going to have a big impact. And there has been a lot of progress over the recent years. But I really do want to warn people about the hype, because I lived through this cycle before and lived through the winter. Recent progress has led to some exaggerated claims. And I've been working in AI for, like I said, 35 years. The field is like over 50 years old, as Fred mentioned. They're hard problems. The human mind is an amazing thing, and trying to replicate it in a computer is not easy. And even our current best methods are a long way from achieving the full capacity of human cognition. Just a couple quick examples on this. There's this idea of adversarial examples that people have discovered, that these deep networks, the current best deep networks, can actually be fooled by specially constructed examples that screw them up in ways that a human would never be screwed up. And they really illustrate that these current methods do not closely model human capabilities. So here's one in vision, where people have discovered that you have something that recognizes digits. And if you just slightly tweak a digit, the system gets it completely wrong. Or if you take a stop sign detector and you just slightly tweak the image in just the right way, these networks get it wrong in ways that a human would never get these things wrong. So even the current best methods are prone to making stupid mistakes. And this happens in language understanding too. We don't have time to go through this example, but there are systems that read a passage of text and then answer questions about them. And some of these deep learning systems, they seem quite impressive. They can answer some pretty sophisticated questions. But if you specially change the text in just the right way, they can easily be fooled in a way that a human would never be fooled and make stupid mistakes. So even the current best AI systems make stupid mistakes if you construct the example to illustrate their weaknesses. This is my fun slide. AI winter. I do believe that AI winter is coming. I am waiting for the new seasons of Game of Thrones. Starts on Sunday. And I am worried about this because the same thing happened before, and Fred alluded to this, that you go through this hype cycle in AI and then it collapses. And I do fear that there is a coming AI winter. When it's coming, I don't know. So just to put some more realism in this rather than hype, I think AI technology is going to have a significant social impact, particularly in employment, in the foreseeable future. But the prediction of this so-called robot job apocalypse, right, where we're all going to become unemployed and robots are going to take over and then kill all of us like Terminator, that is greatly exaggerated. I don't see that on the horizon anytime in the near foreseeable future. And I don't think AI is going to be replacing very creative jobs in engineering in the near-term future. I'm a big believer in AI. I think eventually we'll get there, but it might be 100 years from now because AI is a hard problem. In the meantime, I think we really need to work towards human-AI collaboration. Many jobs in the near-term future will require collaboration between humans and machines. And humans can provide the overarching goals and supervision that require broad knowledge and sort of creativity, and let the machines automate and do the more routine, monotonous sort of chores. So in robotics, there's a standard trope that robots are there to do the dull, dirty, and dangerous tasks, the triple Ds. And I think that's hopefully the near-term future that we have to look forward to. In terms of how this might impact education, I do obviously believe that I think training engineers, particularly engineers, but maybe even a broader class of college students, in the basics of machine learning and data science, because they are so powerful and do have a lot of possible potential applications, is an important thing. So, and Fred alluded to this, that maybe not everyone is going to become an AI expert and get an undergraduate degree in computer science, but we should have some classes. So at UT, in the CS department I'm at UT Austin, we have this thing called Elements program, which is a series of courses for non-majors, and we have one entitled Elements of Data Analysis. So an engineer or a business school major can come, just take a couple classes in CS. They don't have to get a whole CS degree. Learn a little bit about computer science and data analytics, and I think that would be a great thing for a lot of students. We also have a new statistics and data science program, so I think this whole area of data science, we need to grow more programs and educate people more broadly, because I do believe it is powerful technology. One of my last slides here is, I haven't actually read this book yet, but it looked interesting. I just found this, where Amazon actually recommended it to me, using machine learning technology. Of course, Amazon recommended me this book. It's actually by the president of Northeastern University, called Robot Proof. What is the subtitle on that? Higher Education in the Age of Artificial Intelligence. So he says, this is what's the blurb on the Amazon page, at least, lays out a framework for a new discipline, humanics, which builds on our innate strengths and prepares students to compete in the labor market and with smart machines alongside human professionals. So I haven't actually read this book yet, but just reading the basics of it, I'm sympathetic to the point that it's trying to make, and I do think in the short term it's going to be humans working with machines. Okay, so that wraps up my points.
Well, thank you, Dr. Mooney. Let's move on to our third panelist, Mr. Hernandez from IBM.
Good job.
I went to University of Texas, and I'm realizing my only regret.
We all have UT Austin connections. That's great.
My only regret is you didn't give me your brain power when I was there. I should go back to school for sure. So let me share just a few additional thoughts. Jenny, who's our CEO, was on a panelist last week as part of this at-work conference. It was full of chief HR personnel, and she made a statement that I believe, that 100% of the jobs are going to be impacted by AI within 10 years. And if you were to think about that, you would say, well, does it mean that everybody's going to be an AI researcher, everyone's going to be a data scientist? The answer unequivocally is no, obviously not. But if we were to just think about that as an overall problem relative to where we are today, you can begin to sense the magnitude of the issue that we've got when it comes to skills. Today we've got 500,000 open tech jobs. We've got approximately 25,000 researchers, so essentially PhDs participating in one of the 21 major AI conferences publishing. If you were to assess the number of people on LinkedIn, which isn't a perfect measure of the availability of candidates out there, and assess who is essentially a practitioner, either in machine learning or AI, that has equivalent skill, we're roughly at about 35,000 of those individuals. So between people that are publishing in AI conferences and people in the real world working, not in academia, but in industry companies like IBM, we're roughly at about 60,000 people today that know AI in any kind of way. And this is against a backdrop of 500,000 jobs that are open in tech. So if we were to say, all right, all jobs are going to be impacted by AI, you assume some growth rate on the total number of jobs available. Let's call this 500,000 jobs in a decade, a million. Do we have the necessary pipeline to create the skills in AI research, in machine learning, and the kind of engineers that would work in a company like IBM to build these AI tools? But as importantly, and I would say even more important, in the business professionals that would need to know how to apply AI to problems that matter. And I would suggest there's a dearth in that pipeline that all of us need to systematically address. It's a big problem. Dr. Mooney referenced the AI coming winter, and I do believe he is right. If we in academia and in industry do not make significantly more progress in the application of AI to business problems. To give you a magnitude, just to give you a sense of some of the problems that I face, and this is not even referencing customers, just to help you understand kind of the magnitude of problem space that's out there that potentially AI can help with, I'm going to cite a couple of stats that are peculiar to my business. For a business that is data and AI, I spend roughly $150 million in what I consider to be trivial support. This is to say, essentially addressing questions and issues that are coming to me that could be systematically addressed through methods that are generally categorized as AI. I spend roughly $50,000 per translated product to a particular language. I've got over 300 products across my business, and I do business in all UN recognized countries for the most part. And if you were to extrapolate that out, you could understand what my language translations cost are, which is relatively significant. In my contact centers, for my digital operation, which is the preferred way that people come to buy my products, 80% of those requests and interactions that are coming in are not deflected. In other words, the IVR systems, the current methods that we've implemented, are not effective 80% of the time, which is to say, no matter the style of question and issue at hand, it's requiring human intervention, and often with humans that don't actually know the answer, and so it ultimately leads to a customer engagement issue. These are the practical issues that are in the wild that afflict companies like mine, but more importantly, afflict companies like those that I serve as clients. So what is it that we could do together that would help? Number one, I do think that there's a lot of work that we need to endeavor to do in order to have a crisp point of view of what artificial intelligence is. The pundits, vendors, AR, analysts like Gartner and others, not to mention the media, aren't just overhyping artificial intelligence, but aren't necessarily promoting a clear definition of what it is. I was visiting a West Coast VC firm just a few weeks ago, and I was asking what their investment thesis was, and specifically around that investment thesis, what their definition of artificial intelligence is that they would use as a filter for inbound deals. And what the partner advised me of was that he will not look at a company that is employing artificial intelligence techniques, specifically that are not deep learning, and in the case of deep learning, that are using human intervention methods. In other words, people that are applying data quality remediation steps to their data. And I thought about that, and I was like, well, that's probably good for your investment thesis. It's probably helpful for you to get high-quality, leading-edge tech companies into your pipeline, but it's not a particularly helpful definition when you're talking to clients that happen to be insurance companies, banks, wealth management firms, retail, and yet his consortium of people inside of his team are propagating that definition, which doesn't at all say what artificial intelligence can do practically inside of their business. And it isn't at all consistent with other vendors, including IBM's. And so we all need to grapple with this clearer definition of what artificial intelligence is and ultimately mapping it back into problems that matter. On the problems that matter, just a few words on adoption. So I am a data and AI business. I do not represent the IBM research firm business, which is run by Dario Gil. We've got many hundreds of PhDs focused on AI in particular. We rely on their leading edge technologies to promote or advance technologies that ultimately we're commercializing as products. But in the wild, and just a word on adoption, there was a recent survey that was published out a few months ago, and they were surveying managers, executives, not in technology firms, but in end user companies, and they asked them, do you believe in the impact of artificial intelligence, either in driving differentiated competitive advantage to you, or in enabling insights that might ultimately lead to some business and business model advancement? And unequivocally, roughly 80% of those 3,000 respondents had said, yeah, it's going to either lead to competitive advantage or it's going to lead to a potential new business model. But then when asked, that same cohort were asked, and what are you doing in terms of spending money and executing on your projects to enable such differentiation or business model transformation? The sad reality was less than 75% were actually implementing anything. And of those 25% that were implementing something, only 5% were implementing stuff inside of the firm we like to refer to as implementing in anger, which is to say implementing towards a problem against a business case that has positive economic impact or leads to higher client satisfaction. So Dr. Mooney, on your, are we headed to another AI winter? I would suggest that if we don't flip that around within the next 2 to 3 years in terms of adoption, I would say unequivocally the answer to that will be yes. Now let's talk about skills. Actually, before I transition to that, another word on adoption. With the clients that I speak to, and I speak to all the major firms in all the major markets that we do business with that are implementing artificial intelligence, as a general rule, one of the things that they are struggling with is not in the experimentation of artificial intelligence to prove that it works within the context of a particular problem. It's actually deploying some of the stuff. It is true that the machine learning or even statisticians that happen to be data scientists that are inside of these firms are extremely effective. But when you consider that the vast majority of these individuals are building stuff that's worthy of experimentation but not being deployed, it represents a significant amount of money that ultimately isn't leading to any kind of business value at all. And so the question becomes why? No doubt that there are certain technological gaps that need to be addressed through a combination of open source and commercial technologies that firms like IBM, Google, and others should be advancing. But I would argue a critical and probably the most critical factor is one of skills. In general, these firms have gotten pretty smart in creating programs and filtering for candidates that represent the ideal machine learning expert, the ideal AI expert, whether it's for statistical machine learning or other techniques. But what they have not mastered is filtering out those candidates that have the necessary interdisciplinary skills to apply that stuff. At the end of the day, the problems that I was enumerating through, the magnitude of support cost, the issues that are getting in the way to high customer engagement are known by the business. They're known by the experts that have the P&L responsibility, but they're often not understood, not appreciated, and not understood by the technical staff that are inside of these many centers of excellence responsible for applying data science and AI. And it isn't because they don't want to, it's because they often just don't have the skills to be that bridge. And so, similar to what the University of Texas is doing with the Elements program and perhaps double majors or even minor programs, what I would suggest would help us in advancing artificial intelligence overall, but in the adoption of it in the constituencies that I serve, will be to take the business and even the social sciences that are making it away in the business and helping them understand the practical applications of artificial intelligence so they could be better problem matchers. There's a lot of disconnect between the engineering and technical work that's happening inside of these institutions and the pain and the problem space that's happening out. The other thing that I'd like to add is that while high tech overall has a gender and underrepresented minority problem, it's especially acute in AI. I was reading a global AI talent report, which I was actually using to cite some of the statistics around the number of AI researchers and people in the industry applying this stuff. What I discovered is only 18% of the researchers and approximately close to that of the practitioners in the industry are women. And if we want companies that represent the society and the businesses that we serve, I would suggest that the number one place that we could do to affect change will be inside of our institutions, like the ones that you represent here. At IBM, I take this very seriously. I've got some programs that are making a difference in terms of recruiting the best and the brightest that happen to be women and minorities, and I'd be happy to share some of those best practices with you if you'd like to understand more. With that, I'll cede the floor.
Maybe as we transition here to the question and answer period, and if you have a comment or question for the panel, go ahead and raise your hand and we'll get a microphone to you. But let me just sort of start it by kicking off. You all warn of the coming winter, and we all know we're sort of at that peak of the hype cycle, so I guess it's a big question of how far down is the reset? And are there practical things that need to be addressed that we should be helping students prepare to focus on that can maybe ease us into that and not make it so severe? So maybe, Daniel, you're at the spear's tip edge of that. We'll start there and then see if anybody else wants to jump in.
The vast majority of the impact that we're going to have in business is eradicating the boring of business. You know, I'm excited, by the way, I'm as excited as anyone around some of the leading advantages of artificial intelligence that's happening in industry and research, including my own corporate research firm. But the impact inside of our clients are the boring things, actually eradicating the boring things. A simple thing like incorporating case studies into our curriculum, focused on not necessarily the exciting, well, actually you should do that for pipeline, you know, to increase your pipeline, but balancing that out with real world problems that afflict the majority of the firms that exist, I think would be helpful. What do you think?
I'll offer up a quick comment, maybe a little bit more general. The National Academies was funded by the National Science Foundation about 2 years ago to address the issue of the soaring computer science enrollments. The National Academies issued the report about a year ago, and basically the finding was, so you know, to your question about, you know, is AI winter going to happen? They basically made the results of the study were that there are plenty of students who want to pursue computer science, but there will be problems from a capacity perspective that universities can't train all of the students, right? We need young people to foster the growth of the you know, technological competitiveness or economic competitiveness, and the extent to which universities aren't able to keep up with the demand, keep up with the capacity, will just limit the sort of brain power going into the field. And I think that does translate into AI. If you have just the best and the brightest and the sheer numbers of people with ideas that want to pursue the field, can pursue the field, will I think help prevent the winter. So I think there is something universities can do to get the best and brightest you know, in the classes.
Yeah, so I mean, the reason why I try to promote this idea that AI winter is coming, not because I want it to come. In fact, I'm trying to prevent it from coming, because what I saw from my experience from the boom of the 80s was the thing that caused the winter was people's overly optimistic expectations. And so I want to try to promote the idea that AI is great. No one loves AI more than I did. I literally wrote a paper when I was 17 years old in high school on AI, and I've pursued it my whole life ever since. And I'm dedicated to it, and I believe in it, and I believe that it can make the world a better place, as they say in Silicon Valley. But I worry that people's expectations right now are too much.
Yep.
So the only reason I bring that up is to sort of say, hey, AI is great, we're doing a lot of great things, but it's not going to take everybody's job tomorrow. Maybe in 200 years, and so let's have a little bit more realistic expectations, and I'm hoping that will prevent the winter, because then people won't expect and they won't be disappointed. The manpower thing, person power thing, I think is an important issue too. And so just one statistics, I chaired our PhD admissions committee last year. In other areas of computer science, we accepted 20% of our PhD applicants. In AI and machine learning, we accepted 4%. Wow. Because we have so many and we don't have enough AI faculty to mentor them. So we have been pushing to hire in AI. Believe me, I'm director of our AI lab. Nobody pushes for that, hiring more AI people more than I do at UT. And I think we do. And there are a lot of brilliant young minds that have come into the field. And so there are a lot of people, and a lot of them don't care so much about money, and they would love to go to academia. So I think if we can make more academic jobs in AI available, there are the bright young minds that can fill those jobs. I see them every day. I'm obviously a big believer in, if we can grow the number of faculty we have in AI at all universities to absorb all these brilliant minds that we're generating. One issue that hasn't come up is the growth in China. There was a book written by Kai-Fu Lee called AI Superpowers, how the US is going to battle China for the future of AI. I have sort of mixed feelings about that book, but it's interesting reading. I do recommend it, because there is huge interest in China. I gave a talk there at this thing called the 21st Century in Computing meeting in Harbin, China, a year and a half ago. And there's so much enthusiasm of the students in China in AI, and there's so much interesting things going on in China. And I don't think that's a bad thing. I think that's a great thing. We're bringing more minds into the field. But I do believe that then the US does need to up its game. If our technology development is going to match, that in China, we have to up our game in AI, because China is definitely investing a lot of resources in the field.
I just want to add a comment with respect to what Dr. Mooney is saying. China is investing a lot in AI, data analytics, and machine learning related research. In fact, DARPA, they just announced a program in September 2018, investing $2 billion over the next 5-year period. And if you look at 2017 funding, again, a similar amount of funding was invested in AI. So there is a lot of interest, both from the government as well as from private agencies, with respect to AI R&D. So I guess that's possibly increased the hype to some extent with respect to the need and the growth of AI. Any comments from that direction?
I'll offer one quick thought, largely related. So the issue of the skills gap has been talked about in cybersecurity for some years now, 5, 6, 7 years. And the US government has put out all sorts of grand strategies for cybersecurity. As the prior panel mentioned, there are these academic centers of excellence thinking of ways for universities to get better. I was asked to testify in Congress about 18 months ago in what I think was the first congressional hearing on the cybersecurity skills gap. I believe there have been 2 subsequent hearings. In my particular hearing, I was the only academic. There was a defense contractor there. There was a cybersecurity company there, and then there was a cybersecurity startup, and they all talked about the need for more and more people and so forth. I sort of, it wasn't directly said, but I sort of felt like, the universities just aren't living up to the capability. When it gets to issues of economic competitiveness, technological competitiveness, national security, and so issues of a number of other countries have also issued their grand AI strategies. So the Obama administration issued theirs in 2016. The Trump administration issued theirs about 3 or 4 months ago. And I'm just waiting for the day when one of us will get called into Congress again to testify to the extent that, if a deficit in AI skills is felt in the United States, to what extent does that become a national security issue? I guess I wouldn't be surprised if that began happening, and hearings will be held.
Well, the president just, what, a month or so ago signed this executive order or
order.
something that AI is a priority for the U.S. government.
True.
So I think we have some questions from the audience. I think the first one right over here.
So we all have to make investments in resources, primarily people, in this regard. And many of our programs have seen dramatic growth in students as it relates to computer science, large part of which is driven by AI. But we also know, you talk about an AI winner, there's been a corresponding drop and increases in computer science enrollments that may not have necessarily correlated with that, but has the same effect. I mean, have these wild highs and then dramatic lows. C and Unix.com are the last two big ones that followed by tremendous declines on the back end. So to individuals who have to go out and hire people, have to go out and hire faculty, of which we hire for 30 years in many cases, what would you recommend for us to do in this regard?
So I personally don't think, if you make wise, sort of thoughtful investments, and right, if you hire a professor that gets tenure, you're hiring them for 25, 30 years or so. I mean, if they are a wise investment, I just don't think it's sending money, sending good money after bad money. I just think it's going to be a worthwhile investment.
So, I mean, I think when we talk about AI winter, it's sort of where the current demand is, but already the ability for us to educate AI professionals is way below that demand. So I think even if winter happens, that'll just bring the demand down back more to where the educational supply can meet it. So I don't really think there's a real, threat that if you hire a bunch of AI faculty, that suddenly there's not going to be a need for them in another 10 years. I think right now we're just undersupplied, but then once the winter comes, maybe we'll just be at the right level.
On the industry side, in IBM, we have about 380,000 people. 50% of that 380 are new to IBM over the last 5 years. So we're hiring a lot of talent. We spend about $500 million right now reskilling our existing teams. So that isn't just the rest of the 380 that aren't new, but even the new folks, reskilling them in artificial intelligence and related data disciplines are a critical aspect of what reskilling means. There is no such thing as a permanent job in any real commercial institution anymore. And so when we're applying filters for the kind of candidates we want, especially in a field like mine where I'm basically in the product management discipline, our job is to allocate capital to key initiatives, solving big markets, big problems in a differentiated way. I'm looking for critical thinking, number one, and then the requisite technical skills as kind of a secondary, contemporary consideration, not the primary. I think if I were to flip it around, I'd find myself, and I think the institution would, with a bunch of people whose relevance will not last. It's only a matter of time before we stop talking about artificial intelligence, just move on to the next thing. And I think that's going to be natural and not necessarily a consequence of the overhype. It's going to be natural because the novelty is going to wear off. Once it becomes actually when AI becomes mainstream, I think there's going to be one or two phenomena. So we're going to quit talking about it. We're going to assume that it's been overhyped and therefore not making an impact and move on to the next. Or actually, we're going to celebrate kind of the acceleration of AI to it. So at least from where I sit, and in the non-research space, so I'm responsible for products, I don't hire first for AI skills. I don't hire first for data skills. I hire first for critical thinking skills with the necessary contemporary skills, which ultimately comes down to statistics, social science, math, and computer science as kind of
Let me make one more comment about hiring. There are these quotes that I've heard where people say in computer science with the soaring enrollments, 2% of the faculty are teaching 20% of the students. You see sort of quotes like that. And in some sense, you've got faculty who are extremely overburdened, they're overworked. Think about hiring faculty as a, kind of, a hedging your bet sort of investment. So if you bring in some top-rate faculty, and sure, you may need to have them there for 25, 30 years, a couple of other of them will split. I mean, a number of the people that I knew at UT Austin are now gone now. They're working for Amazon, they're working for Intel, they're working at a bunch of other places. So you're hiring people, you'll keep them around for a while. Don't be surprised if they don't stay for 31 years. They may just get a terrific offer in the private sector and off they go.
All right, as we come to the close, I think we have one more audience question.
Yeah, so my question for perhaps the academics on the panel and perhaps the others as well, what's your thinking on the schools of computer science that are popping up? Of course, at MIT, CMU's always had one. Good idea, bad idea?
So are you referring to colleges of computing?
That's right, yeah, colleges of computing, separate from either engineering or the sciences.
Yeah, so I think there are going to be more of them. Again, it's this soaring enrollment problem. So I referenced the National Academies report that came out about a year ago. Again, it was funded by the National Science Foundation. There have been surges and declines in computer science enrollments over the years. So, right at the time of the internet burst, sort of year 2000, there was a big rise, then a decline. It was the conclusion of the National Academies Committee, and it was a very thoughtful group of people, that the rise that we're seeing now, and it's basically been since about 2009, so for about the past 10 years, we've seen a steady increase. They basically conclude that the rise is going to continue. It's not a short-lived thing. And so if you just continue to see this rise, it starts making computing a really important discipline. In the case of MIT, I thought it was of considerable interest. So my son's a graduate of MIT. And so there's section 6.1 electrical engineering, 6.2 computer engineering, section major 6.3. That's all actually moving into the School of Computing. Their new School of Computing, for which they are investing $1 billion, all of the engineering disciplines are actually moving into the School of Computing. So MIT's made that decision.
Yeah, I mean, I think it is an inevitable effect of the growth of the field that, this idea of colleges of computing and then more specialized departments, and having a specialized department on machine learning. CMU has that, on AI, and have degrees in that. I think it's a natural progression of the growth of the field of computing. I mean, I guess initially engineering was just one department, and then it grew into a college, and we got electrical engineering, mechanical, industrial, and I think the same sort of thing was recapitulating in computer science. So I would expect that to continue in more universities to create colleges. We've talked about it at Austin, except there's various issues. We're actually in the College of Natural Sciences, the computer science department is, so we're not even in a college of engineering. But I think there is a natural progression towards colleges of computing and then AI just becoming a department within that.
So maybe we can end on an uplifting thought. In one sentence, what's an application of AI that you think that you are personally most excited about the future for? Fred?
It's easy for me, the intersection. So this was this workshop that I chaired last month. So it is the intersection of AI and cyber. So you heard from the previous panel about the challenges relative to cybersecurity. We basically went way deep into the question, how can machine learning and AI assist in cybersecurity, assist in cyber defense? Very hard problem, very interesting, passionate about that.
Ray?
So my main area these days is natural language processing. So I'm a big believer in, if you all have your Alexa or Siri or something, but if you ever tried sort of unusual types of queries on that, they're actually quite limited in what they're capable of. But I really think a really good sort of, agent that you could talk to in natural language and could do things for you in an online fashion that really understood language more deeply, I think would be a great thing. And of course, Amazon and Apple and all these are working on extending, Alexa and Siri and things like that to be more capable. And I think that's a very exciting space.
I would say cybersecurity, number one, but there's also a place that we're investing in that could have dramatic impact for our clients. Net retention basically is a measure of how effective you are in keeping your clients and having them grow, which won't happen unless you're successful. A single point of net retention increase for our clients could represent up to $100 million of enterprise value to them. And so this broad space of customer care, and there are derivative disciplines around employee care, to me is one of the more exciting spaces, because if we could apply AI, there is clearly going to be a business case with high economic consequences, and if we could repeat that enough across a lot of industries, the trail of success will be high, and people can't say it's all hype, it doesn't matter to core businesses. So customer care would be my second.
All right, well, thank you so much for all of our panelists. Let's give a big hand to all of them.